Hello everybody, my name is David.
My name is Lucas.
And today we'll be talking about promises and await. So before we start, we wanted to define a few terms that we'll be using throughout this lecture. And for our first term, it's going to be, okay, is this better? Is it better? Okay, cool. Okay, cool. So just to define our first term, it's synchronous. So synchronous essentially is a process which happens consecutively, where you have one thing happen after another. And to use an example, basically we have, for example, classes where we have 6100A and then 6101. 6100A is a prereq for 6101, so you have to take one before you take the other. Yeah. And for asynchronous, asynchronous is different, where it's an idea where multiple processes can run at the same time. So using that analogy earlier, you can have, for example, if you're taking a Haas class and then 6101, if they don't have any conflicting prereqs, then you could take both at the same time. So to start off, we're going to use an analogy where we have Abby, an avid cat lover, who wants to buy cats from a catalog. So in order to do this in today's society, you basically would go to an online retailer, a massive online retailer, place an order. And then after you place the order, after some time passes, you can have one of three things happen. The first thing that can happen is if everything goes well, you can have the package get delivered. Abby's happy, everyone's happy. You can have another scenario where you can have the delivery get delayed. So Abby's anxiously waiting for the package. And lastly, and I guess disastrously, something can happen to the package where it can get lost. And as you can see, Abby is very sad. So in essence, this analogy also fares very well for promises as well, because after placing a delivery order or creating a promise, you can have one of three statuses. You can have fulfilled or resolved, where the delivery is completely successful. You can have pending, where the delivery is just currently being in like this middle state between like being fulfilled, or you can have it be rejected, or something happened, something wrong. So applying this idea to .then, this should be a bit of a review, but basically we have, let's say we have a post request, and this post request essentially, using our analogy earlier, represents a order that Abby would place, where this is basically our initial order for the cats. And from this order, if the promise is fulfilled, then we can use a .then, where this would represent our delivered cats, and let's say the cats are delivered, we can do, like, for example, a hug function where we hug the cats. If the promise is rejected, then we could do other things where, for example, we can use a .catch method where if something went wrong, then we can, for example, log it, say, oh no, something happened here. And just to be very clear on the idea of what, like, for example, in this code segment here, what story objects means, this represents, in the case where it's fulfilled, it represents the cats, or whatever object we want to retrieve from the promise. And just to reiterate, if we have an error occur, if we have the .catch method here, we can easily log that mistake, or log that error that occurs, and very easily tell that something went wrong. So back to this idea of synchronous versus asynchronous. So let's imagine Abby is operating in a synchronous process where, in essence, when she places the order, she can't do anything in the meantime, where she just simply has to wait until the order finishes before she can do anything else. So the delivery comes, the order is placed. Once again, she can't do anything in the process. Delivery comes. But let's say she wants to do something else in the process. Let's say she wants to cook. Let's say she wants to lecture the lecturers. Let's say she wants to get gains. She can only do these things and also not do the orders. Basically, she can only do one or the other. And let's say she goes back to placing an order. In that case, she can only place the order and then wait for the delivery in the process, as you can see here. However, basically one of the big things here is that this wastes a lot of time. And if we compare this to an asynchronous process, what Abby can do instead is place the orders. And while the orders are being delivered, she can cook, she can lecture the lecturers, she can get swole. And in the process, these deliveries are coming in the background. And in essence, this is the difference between synchronous and asynchronous, where in synchronous, basically, Abby can only do one order at a time, while in asynchronous, she can do multiple orders at the same time. And just like promises stop Abby from wasting her time watching her orders, promises can let us run other code in the background. So what does that look like in code, right? In terms of this, we have a use effect here, right? And this use effect we call a asynchronous function, which is our cat orders, which Abby would place. And in this case, we have a slow cat order, then we have a .then, where once the order is fulfilled, then we do console.log of the cats being delivered. Now, basically, yeah, this idea of like we have our slow cat order, and then we have our callback function, which if the order is fulfilled, then we do this. Now, let's say we have some code that's outside of that function, where we have console.log of, once again, cooking some food, lecturing the lecturers, and getting gains. Now, I want to take a few seconds for you guys to just consider. Even though this code is run in order, if we were to run this code in the terminal or just run this program as a whole, what do you guys think will happen? Will the cats delivered be printed out, or do you guys think that do you guys think that something else will happen, where maybe the console.logs later on will be printed out before the slow cat order is finished? I want you guys to take like 5 seconds to consider that. Yeah? Yeah, exactly. Basically, in the next slide, this is the idea I'm showing, where let's say we have like that blue region where the blue region represents the slow cat order, and then the red region represents our console.logs in the background. As we see here in this output, even though the slow cat order is written first, we can have a case where the other console.logs are printed first, and then the slow cat order is finished, which represents this idea of asynchronous, where the slow cat order is running in the background while the other console.logs in the red region are being run. Yeah, pass off Lucas.
All right. So can you guys hear me in the back? Thumbs up? All right, cool. So now we're going to be looking into using multiple promises. So we have this piece of code here. I'll give you guys like 10 seconds to parse it. Essentially, what we have is slow number, which is an asynchronous call, which takes in an input, some number, and returns it to our front end after 1 second. So essentially, what slow number returns whenever we run this code is first a promise, and so A and B are promises. And at the end, we console log A plus B. Now, I want you guys to take around like 10 seconds to think about what the console log would actually print. And put 1 finger up if you think it's 19, 2 fingers up if you think it's 910, 3 if it errors out, and 4 if it's object promise, object promise. Come on, guys. All right, see some 3s, some 4s, 3, 4. Okay, cool. It actually prints out object promise, because JavaScript just interprets A and B as promises and then concatenates them together. You would expect that we'd actually want to add up the numbers that these promises return. And so in order to kind of unshell the promise and get the value that we want inside, we need to wait for these promises to actually resolve. And so you guys know how to do this. You guys just use .then. So .then waits for our promise to resolve and then runs some callback function with the data that we receive from our asynchronous function call. So here, a.then, that waits for promise A, and then it runs our callback function, which takes in eval, and then waits for promise B to resolve as well. And so then we just console log eval plus bval. And now that we're going into dealing with multiple promises, there are multiple ways to actually create behavior from multiple promises. So we'll look into that. So assume that we have multiple promises. We send a GET request to our server for some comments with different parent IDs. And so we have our 5 promises, and we put them in an array. We can make a promise out of all of these promises. And so what promise.all does here is it resolves if all of our promises in our array resolve, and it rejects if at least one of the promises in our array rejects. So you can imagine that maybe on our Capex server, we want all of our comments to render, and if one comment is not retrieved correctly, then we don't render anything at all, and we run our error callback function that is in .catch. So if all the promises resolve, we run our functionality in .then using all the information. Otherwise, we run the callback function in catch. Any questions? All right, cool. Now let's look at promise.race. Promise.race essentially takes in our array of promises and then waits for the first promise to either resolve or reject. And depending on whether that promise resolves or rejects, we run, or rather, the promise that we return resolves or rejects. So if, let's say, promise 1 is the first to resolve, then we run the .then callback function with the data that promise 1 retrieves. But let's say, in another case, promise 4 actually rejects first. So we get a result from promise 4 first. Then we run our error function with the error that promise 4 returns. Any questions? All right, cool. Then promise.any takes an iterable of promises and rejects whenever all of the promises reject, and resolves if at least one promise resolves. So you can imagine that promise 1 rejects, promise 2 rejects, promise 3 rejects, but then promise 4 resolves. So we use the result from promise 4 inside of our .then callback function. And yeah, but if we have the case where all our promises reject, then we end up running the callback function in .catch. All good? Okay, cool. Now let's talk about async and await. So in order to actually understand why we use promises, and this is just like reiterating the example that David showed us, let's talk about a synchronous program and an asynchronous program from the view of like actual code. So imagine that our red block of code depends on our orange block of code. So our orange block produces some data that our red block must use. And so our orange block must run before our red block. And it's also supposed that our orange block is not dependent on our green block. So if we wanted to, we can execute them in whatever order we wanted. And so in a synchronous program, we would have one piece of code ran after the other. We can't run them at the same time. So we would run our green piece of code, our orange piece of code, and then our red piece of code. And this would end up taking 6 time units. However, in an asynchronous program, this is where we take advantage of the fact that our green block and our orange block are not dependent on each other. So we can run our green block of code, but while our green block of code is running, like maybe we send some API for some data that we know that our red block of code will need to run, then that API call can be ran on some other computer other than our own, and we can run our green block of code. And so by the time that our API kind of finishes, it's going to return that information to our own local computer. And once we finish our green block of code, we can simply transition into the red block of code. And in this case, instead of 6 time units, we actually just run our program in 4. And so now let's talk about await. So if you guys remember the example that I showed you guys earlier, we actually need to wait for our promises to resolve in order to use the data that our promises hold. And so one way to do this is to use the .thens that I showed you. But you can also use a keyword called await. And await just essentially, well, it waits for our promise to resolve. And so here's, and I'll give you guys some practice questions to consider, like how long a program will take using just like waiting for promises. So in this example, we send a GET request to some URL and then immediately await it. We send another GET request, we immediately await it, and then we console.log. If A takes 3 seconds to await and B takes 5 seconds, how long do you guys think it will take before we print something through our console.log? And I'll give you guys like 15 seconds to think about it. Okay. Now I want you guys to put up the number of fingers you think, or how many minutes or seconds do you think it will take to actually execute this code or to actually print it out? 5, some 5s, 3. I see an 8. 8. Okay, cool guys. Cool. Okay. And so this actually takes 8 seconds. And the reason behind this is we send our GET request to random URL, and we immediately await it. So we send the request, all the work is being done on some other computer, and we simply await the data to be returned. So we're not doing any other work on our local computer. And then that's, in order for our GET request to actually retrieve information, it's going to take 3 seconds. And then we move on to the next GET request. And then we immediately await it. And that's going to take another 5 seconds. So in total, it's going to be 8 seconds. Now, this is another example. So what if we actually do these GET requests before we await them? And I'll give you guys another 20 seconds to think about how long this would take if A takes 3 seconds to await, B takes 5. Yeah. All right. So it's actually 5. And I want you guys to turn around, talk to your neighbors, and if you guys have any differing answers, explain why you think it's 5. All right, let's bring it back now. So whenever we send our GET request to random URL and other random URL, you can imagine that we have 2 different computers that are doing separate work. And so the moment that we send those GET requests, the work that they have to do starts, and then we start awaiting promise 1. And it would take, whenever we await promise 1, we know that it's going to take 3 seconds. And so we await promise 1, takes 3 seconds. And in those 3 seconds, both of our GET requests are being processed. So our promise 2 has already done 3 seconds of work. So by the time that we get to awaiting promise 2, we only have to wait 2 more seconds for it to resolve. And so that's going to end up taking 5 seconds. Any questions? All right, cool. And now I'm going to give you guys a final example. What if instead A takes 5 seconds to await and B takes 3 seconds to await? And so I want you guys to talk to your partner, probably like go through the code and explain your thought process. All right, cool. Let's bring it back now. So this actually takes 5 seconds as well. And so similar to our previous example, we're sending both GET requests. We await promise 1. Promise 1 is going to take 5 seconds. And so we do 5 seconds of work for both of the requests. And by the time we get to promise 2, well, we've already done 5 seconds of work, and we've only needed 3 seconds of work. So our promise 2 has already been resolved. And so we don't wait any extra time. And so by the time that we console log done, 5 seconds have passed, and that's it. And so the thing about using await as opposed to .then is that only asynchronous functions can use await. And so what does it mean for a function to be asynchronous? Well, it just means that we use the async keyword whenever we define the function. So we just use async. And then inside of that async function, we can freely use await. And so now let's put the await code and the .then code side by side. So imagine that somewhere up in the code, we do our GET requests for A and B. And then we simply want to await for those promises. And so for our function that uses await, it's as simple as just await A plus await B. And then for our .then, it's a little bit uglier since we're nesting in like 2 .thens. And whenever we're awaiting multiple promises, it can get a little bit ugly. And so this is just like one benefit of using await as opposed to .then. Another difference between using await and .then is that for traditional promises, we use .then. And so for our use effect, if we have a GET request, we simply get the data from that GET request and then run our callback function. But for use effects, we can't have asynchronous callback functions or inside of use effect. And so in order to actually run our await function, we have to define a getStories function inside of our use effect callback function, so inside here, and then actually call getStories. Yeah, so that's just like a small difference that you guys will have to take into account. Questions? And I don't know if I have enough time for this, Abby. No, okay. Cool. But if you guys have any questions or have ever wondered like how JavaScript actually handles async calls, please go to office hours. Like maybe it's a little bit confusing that like we wait for promises and then we run a callback function. But when do we actually have the time to run that callback function if we're like running other code? So if you guys are interested in that, please come to office hours and I'll do the mini presentation there. All right. And so when should we use asynchronous functions? And so we use async functions or like API requests, or rather our promises, whenever we have background tasks that we don't know how long these background tasks will take. So for example, it could be fetching data or downloading / uploading data on YouTube. And it's very important to realize why promises contribute to user interactivity. Let's say we're on YouTube and we're waiting for everything on YouTube to render. So we're requesting videos, we're requesting comments, but we can still scroll through the YouTube app or YouTube website even when some videos haven't rendered. And that's very important because if we used synchronous, or if our website was synchronous, then we would have to request all of our data, and then only when we have received all this data, we can scroll through our website. And so, yeah, that's just why asynchronous functions are important. But yeah, I really appreciate if you guys gave us feedback. It's really important for us to improve our lectures. But thank you guys.